Okay, thank you. So this morning we have Dr. Charlie Hatcher. He's the state veterinarian from Tennessee, and he's going to give have kind of a discussion about their high path avian influenza response in March of this year, and then we'll have a kind of a question session after that, and then we'll have Dr. Fred Michel talking about his research on slab composting and infrared monitoring of compost windrows using some new technology. So go ahead, Dr. Hatcher.
Good morning. Can you hear me okay?
Yes.
Good. Well, I guess Dr. Bolton's on as well, right? Or
Yeah,
no?
Charlie, I'm here. Yeah, I'm here.
Okay. Well, let me first say that we've done preparation for high path AI for years and years and years, but I really never thought we'd get it. But it's a good thing that we persisted, and we had some preparations underway. One of the things that we did was, or at least we attempted to have every commercial location declare their method of disposal. We did that. There was an abundance of burial as the selection, and we didn't go far enough. At least that's one big lesson that I learned from this is before the next time, or actually before cold weather, we're going to get specific so that they declare a disposal method and send in plans for that. And I'm planning to have that disposal method vetted by a subject matter expert panel so we can say yes or no and approve it before it happens. Because what happened, at least I'll give you the timeline. We had the first high path AI was in, well, all of them were in broiler breeders or were in hens, and they were in barns that they tell me are not conducive to composting. But when I get through, I'm going to ask about that, see if there's some possibilities that we could do some things in the house composting wise. But so after the on all these farms, we had the two high path location. Well, we had the high path location, then a low path location, then a high path location. But in all these, they had selected burial as their method for disposal. And so when Dr. Ballphaser called from the field, or Sean, I can't remember who it was, or determined that they were for sure going to bury, I mean, it was just that's what they were going to do and what wanted to do. So at that point, at least in Tennessee, there's no agency. It's not USDA NRCS. It's not our Ag Extension bunch. It's not USDA themselves. We'll approve a burial site. There's too much liability involved, so that falls on the state veterinarian in the end to say, yes, you can bury here. And so as that process unfolded, I begin to rely on a couple of the subject matter experts, excuse me, that I'm planning on having on the panel to pre-approve. One of them was a state soil scientist, excuse me, again, and the other was a couple of engineers and soil experts from Ag Extension, and then we also consulted TDEC, which is our Environmental Conservation Resource Agency, and we had some issues with them being forthcoming on public well sites for terrorism concerns. And so we're hoping to work through that so that we know the locations of public wells so we don't inadvertently bury in the wrong place. And we almost did. After we got to the first high path location buried, one of the Ag Extension agents said, well, you buried too close to a public well, and then I got a sick feeling in my stomach. But it turned out not to be the case. But the next time we need to have the exact locations of the wells. We need to have the site approved, but it would be my preference. I tell you that burial is wrought with all kinds of problems. To just do composting only, and I may have the authority to do that. It may do that, but it might cause some problems from the companies and the producers. To further complicate it, the companies own the birds, or they do till they die, and then it's the property of the grower. My understanding, and the grower owns the property. So in the end, it's the landowner's approval whether they want to bury or not. So there's several issues with burial because of what they call burial remorse. There's evidence that with some types of burial that carcasses are there for years. So sometimes it knocks them out of the future development if they were going to put a subdivision there. And on at least one of these farms, they dug too deep and they hit the water table. That was a mess. And so I said, well, you got to fill that back in. We'll move over and dig another place. And so I did learn that you don't need to dig if you are going to bury. The soil has to be right, the location has to be right, and I'd recommend, or I've learned that you don't want to dig too deep. Probably no more than, I wouldn't go probably any deeper than 8 or 10 feet. Maybe a little less than that, and have several layers of birds, and then ample dirt over top. So we're beginning planning to figure out how we're going to do. I'm going to assemble this panel to pre-approve sites. My preference is going to be to move to composting. I've seen a couple interesting methods. At least I saw one demonstration of where you could do composting in one of these hen houses. I'm curious about that. If somebody has some comments about that, and also I saw an article that was really intriguing. Is this hybrid where you kind of bury above the ground, so you'd have you wouldn't dig very deep. I don't know how deep, maybe no more than 3 or 4 feet. You do some carbon-rich material, and then you do a layer carcasses, and then you cover with dirt, maybe above ground, 1.5 to 2 foot, and plant some vegetative plant something there so you have vegetative growth. I've seen that, and that looks to be a possibility for me. Then you go in later, and you've got that compost material, and you can level it and spread it. Another problem we had with burial, and I haven't been out to look at the sites. I plan on doing that. I've got to speak at the U.S. Poultry Convention this morning, and then Friday we're having a meeting with our industry, our Poultry Avian Health Committee, to make preparations for the next one and talk about some of these major issues. And I might spring on them that we'll try to go composting all the way. Because really, there's only 2 options. There's burial and there's composting. There's no way that we can go to landfills. And rendering, it's got a bad connotation too. You want to keep the disease on the farm, so you've got an increased chance if you render or go to landfills. So that's kind of it in a nutshell, and that puts me at about almost 15 minutes. So I'll throw my questions out, or y'all can ask questions first, and then I'll throw questions out what I'm interested in.
Dr. Hatcher, this is Gary Flory. Can you hear me?
Yes, sir.
All right. So thank you for bringing up all the issues that you encountered there, and certainly there's a lot of reasons why your industry chose burial. Up to that point, in-house composting had not been conducted within the broiler breeder industry. It's something we've been talking about quite a while, but it just hasn't been done in the U.S. It has been done in Canada, but they have some different housing situations there, and we have some additional challenges here. In Virginia, we've been talking about composting in-house within broiler breeders for a couple of years with our industry, and we just have not gotten around to doing a demonstration to make it work. When you had your issues here, we got together with our industry and 3 of our companies within the broiler that had broiler breeder houses said, okay, let's actually see if we can do this. So we did do a demonstration project with a full house of broiler breeders and did that composting between flocks, and it did work successfully for us. So we think that that is a possibility. We've demonstrated it here in Virginia. All 3 of our companies with broiler breeder houses do intend to do that in-house composting if they do have an AI outbreak. So it is possible. It can be done. We've demonstrated it on a whole house, and be happy to share with you that information.
I think that I may have seen that demonstration, but I mentioned it to some of the industry folks, and they said, "Well, it's not practical. They had some issues, yada yada yada." So they're not totally convinced. So can you do it in a low clearance barn?
Yeah, absolutely. And I'm actually here with Bob Peer, who's also involved in that work. And yes, you can. We had very low ceilings here as well. Our houses, and I can send you some photographs, our houses were very typical of the industry. As a matter of fact, typical of the older houses with the even lower ceilings, and the nest boxes as well, very difficult to get underneath those nest boxes. And like your houses, very likely we have concrete scratch area, and then we have the manure pits to the side. So
yes,
we acknowledge that there are challenges in composting in a broiler breeder operation, but it can be done.
Okay. What about if you couldn't do an in-house, could it be done out of the house? I wonder about weather conditions, rains, and so forth. Is that possible?
Yeah, it is possible, and it wouldn't be a lot different to do it outside than the issues that we had when composting with the layer operations in the Midwest, 2015. So it would be very similar to that. Certainly possible, but as you mentioned, when you do it out of the house, then you do have weather that you have to manage and to work around. But certainly it is very, very doable to do outside composting as well. But you can do that initial composting inside if you want to make sure that you don't have weather limitations. You don't have to worry about that inside. So again,
see,
be happy to.
Advantage to the outside the house, and we kind of fell into this, is we didn't realize that maybe we did realize, but it didn't hit home until we got into it, that the 90-day clock for the BAI free starts after C&D is complete, and so that took forever. So if you move the birds out of the house and you were able to compost while they're being composted outside the house, you could start your dry cleaning in there and get all that done, and potentially move to AI free sooner. That was a big issue.
That's absolutely true. Now, the process that we're using in Virginia, our plans are we're doing that 14-day compost, that first cycle inside the house. And then at that 14-day turn, that's part of the USDA protocol, we're actually moving the material outside the poultry house. So that allows you to start that C&D process. And once you get that C&D done, you can do your 21-day fallow period after that C&D.
Okay.
So basically, it's adding 14 days to that process if you do it inside initially, but it's also making it more biosecure. You're taking out the issues.
Well, that'd be my preference. So in 2 weeks, you can move it outside.
That's correct.
And USDA fine with that?
So there's 2 14-day cycles. There's a first 14-day cycle, and then a turn, and then a second 14-day cycle. And USDA has done that multiple ways. We can do both cycles within a house, or we can do one cycle within the structure, and then when you do that turn, you can move it out and do that second cycle outside of a house. And USDA has been fine with that in the past. And I did see that Lori Miller is on the call. If she has anything to add, she can certainly add that.
Hi, folks. Thank you. Yeah, this is Lori. Thank you for your very informative talk, Dr. Hatcher. Really appreciate you bringing that information to this group. A couple comments I wanted to make. One is that if you would like to do composting, responding to either low path or high path AI, the people on this call, many of them are on the APHIS roster as subject matter experts. And so that means that they've gone through training and field experience to know how to do the mortality composting, which is a very specific type of composting. And there are only maybe 20 people in North America who are able to do it successfully. So if you need that assistance for HPAI AI, APHIS will provide that. And so what we did in 2015 was, as soon as the state requested composting assistance, we would deploy one of the experts, and they were usually on site within 48 hours, if not sooner. And so, we deployed them multiple times in 2015 and during HPAI AI, APHIS picked up the cost of that. For low-path AI, if you want that assistance, I believe that the state would have to contract directly with the subject matter expert. And again, we can provide that roster of contact people. But as Gary indicated, there are 3 options with the composting. You could do it all in-house, and we're just talking poultry here. You could do it all in-house for 30 days. You could do half of it in-house, and then when you're turning it at 14 days, take it outside, or you could start it outside. And we did all of those options in the response over the past few years. So I just wanted to let you know that those options were available. And if you are in a situation where you're trying to decide what disposal option to use, we have lots of resources here at APHIS that we can provide to you upon request.
Well, I don't plan on getting in that situation again. They're going to have to, we'll know that ahead of time this next time.
Great. So I just wanted to let you know that all existed. And the question to you is, Tennessee is not unique in going through this when you're faced with your first outbreak, trying to figure out what's the best thing to do. It would be great if we could take advantage of the lessons that other states have learned and provide those to states that are facing it for the first time. And so my question to you is, what do you think would have helped to get the information to you before you needed it? We have some ideas about setting up a group webinar discussion once a month with state agriculture and environmental folks to talk about these issues. But that's just one idea. What do you think
I think
would be helpful?
It's a matter of education. I knew it was that burial could have a lot of problems and burial remorse, and the state vet in Alabama had told me that too, that there were issues with burial. And so maybe we could do some educational things, excuse me, with industry and the producers. But I'm going to require them to declare this time and present a plan, and it'll have to be pre-approved. And I may go as far as to say in-house composting. Maybe, because it's just the burial is just is too filled with so many problems.
Thank you for that. And I know that Gary Flory also has a lot of insights on that above ground burial you were asking about. So I'll turn it back over to Gary if you want to talk about that.
Yeah, that hybrid option looked pretty interesting too, because even with these burial sites, we had some sinkage of the dirt, so that it's a real mess because it was wet. The guy's property doesn't look good. I haven't been out to see it, but Dr. Ballphaser said it's not ideal. It's going to have to be leveled and filled and all kinds of things like that. So I'm sure if I was the landowner, I wouldn't be too happy about that.
So, Dr. Hatcher, this is Gary Flory and Bob Pierre again. So just to let you know, we have also done a project with above ground burial, and I think that paper that you have looked at is probably based on the work that we've done. We were really looking at above ground burial as an option for livestock primarily because of the issues with how to deal with that volume of material. So principally that was our thought when we moved into that. However, it may have some some usefulness for poultry as well, and we're currently working with Louisiana, and we're also working with Mississippi, looking to do some demonstration projects for poultry, because there seems to be a need for that as well. So again, our intention initially was livestock. There may be some utility for that methodology for poultry, and you know, there certainly is some different issues that you need to look at, primarily being that poultry are going to lose their decomposition products much more quickly, so you need to manage that. But if you're in a situation where you think that you must bury, we see that above ground burial offers significant potential for better environmental protection than traditional burial so close to the groundwater table. So Bob and I would be happy to chat with you about that as well at some other point.
The producers just thought in the companies, I guess the companies thought in their mind, you know, get them in the ground as soon as possible, get them out of sight, out of mind. You can start cleaning things up. And we didn't realize that it was still, we had issues even doing that. So, you know, if we could educate them and let them know that this is not going to slow the process down, this is the least chance of disease transfer. It's safer for everybody involved, or easier for everybody involved, less chance of contamination.
During our work with our industry here in Virginia, when we're talking about that extra time that it takes to do that composting in-house, within some sectors of the industry, 14 days can be pretty significant. But generally speaking, our broiler breeder industry is saying, you know, once we get out of our cycle, that additional 14 days is really not going to make or break us, because it's probably going to be a while before we get birds back in those houses anyhow. So it's possible that within the broiler breeder industry, that extra 14 days is even less critical than perhaps within the broiler industry or the meat turkey industry. So
yes,
that's where, where we're.
We depopulated within 24 hours. We buried within 24 hours after that, and we thought, well, we got this licked, and then we got stuck in the quagmire on C and D.
Yeah, this is Bob Peer. One of the other thing that in Virginia that our broiler breeder industry, as well as the turkey, one of the reasons they were obviously, and Gary brought this up earlier, was keeping them in house. As far as disease transmission, we have a lot of areas where we have a lot of poultry houses in close proximity to each other, and so the industry here was very, I reckon, concerned about bringing the birds out of the house, whether it's outside composting or whether it's so that was why we were, over the last couple of years, looking at trying to come up with a way of doing the breeder houses inside, doing in-house composting.
But Dr. Hatcher, we'll turn it back over to you. We didn't mean to monopolize here.
No, I don't mean to monopolize either. I'll just see if there's any more questions.
Good morning, Doctor. Good morning, Dr. Hatcher. This is Doris Olander, VMO EPI for APHIS in Wisconsin. And if you hear something loud in the background, it's not because I hold all the power. We've got a great thunderstorm going through. One of the concerns that, listening to you, I've done this a long time, is before you approve burial in any way, the post-burial liabilities should be considered for both the state and the landowner. Because if in some states the state's waters become polluted, that doesn't release, because you've approved it, does not release that producer or landowner from liability. And in Wisconsin, that's both criminal and civil liability.
Yeah, you're not telling me anything I don't know. That's why I was nervous the whole time, and we're going to do it different. See, I got approval by subject matter experts, but still that didn't release you. But I didn't get full cooperation with our environmental agency disclosing where the public wells were. It was a mess. So I'm not going to do that again, ever.
Yeah.
No, I realized that when I was doing it. But I mean, what are you going to do? I mean, you got you got 150,000 dead birds total between 3 farms. You got to do something with them. Nobody will take the say yes, you can do this. Going to want to bury. So I took the information I had and we did it.
Yeah, I understand that. I worked in the UK and arrived there when there was 200,000 carcasses on
But
the
it's
ground.
interesting. I mean, nobody else will approve it. Not USDA, not USDA, APHIS, or NRCS, or Ag Extension, or anybody. At least in Tennessee. I don't know if it's different anywhere else. Will anybody approve it in any other states besides the state vet?
So this is Lori Miller. So ultimately, it is up to the state environmental agency to determine if burial at a particular location is safe or not. So that authority is delegated from the federal government to the states. And so we, as the federal government, can't make that decision for the states. It's the states who have that state-specific information. So,
I know that, but our state agency, they won't have anything to do with it. They don't want to contaminate the water of the states, but they say the farmland. We have a law that says a farmer can bury his own livestock on his own farm, as long as the waters of the state are not contaminated. So,
and there's the catch right there.
But yeah, so they won't give an approval either. I promise you.
So maybe planning is the way to go, and
that's the way we're
I can shoot you. Yeah, and I can shoot you an email after this call and to provide you with some like state plan templates, farm plan templates, things that might be helpful.
Looks like composting's the way to go.
Great.
Altogether.
So I can send you some templates if that would help.
Yeah, sure.
Thank you.
So, well, thank you. Any more questions for Dr. Hatcher? I know he has to get to a talk this morning. Well, thank you very much. We really appreciate you, sharing your experience and your insights, and I think that'll be helpful to a lot of other states in the future. So,
well, thank you for inviting me. So, is this a regular meeting or is this just occasional?
Generally, we have it once a month, once every Wednesday, about at this time, and we alternate kind of with a webinar and a discussion of with the composting group. So there's about 90 people who are on the call.
Well, I wouldn't mind listening in from time to time when I can.
Sure, we'll go ahead and add you. We can add you to the list, and you can join the calls every month. So.
And I'll hang on a few minutes, but don't take offense if I drop off.
Okay. All right. Well, thank you very much. We appreciate your joining us. Thank you.
I appreciate everybody's expertise.
Thanks. So we'll go ahead and move to Dr. Michel. So he's going to be presenting some information on his research into a slab composting technique and also using infrared monitoring for temperature in compost windrows. So go ahead, Dr. Michel. I don't hear you yet. I think you're still muted.
Okay. Is that better? Can you hear me now?
Yes, I can hear you. Yes.
Okay. And my presentations is shown there?
Not yet. Yeah.
Okay. Let me see. I was having trouble yesterday getting this to work. Let's see. Share screen.
So Dr. Michel is an associate professor at the Department of Food, Agricultural, and Biological Engineering at Ohio State.
Yeah, let's see. Can you see it now, the presentation?
No, Dr. Michel,
no,
click the share screen and then you can choose your application or you can choose to share the entire screen, but then you'll want to hit start sharing.
Okay, there we go. I see it now. Okay, how's that?
Perfect.
Better.
Thanks.
Okay. All right, thanks a lot. Actually, I was just promoted, so I'm full professor now. So that's
Great.
the next thing. But I come from this from a different angle. I'm really, my research has been a lot of work in the composting area, designing composting facilities for manure, yard trimmings, food waste, and other materials, and not so much mortality composting. So understand that as we go through here. We were looking at the outbreaks in Iowa and then looking at our farms here in Ohio to try to prepare for an outbreak here. And we noticed a few differences in what's going on here versus some of the work that had been done before in composting of these mortalities. First, let me just mention some of the collaborators I work with. One is from the Ohio HPAI, Harold Keener in our department, Mo El-Ghazar, which you may know, he's the OSU veterinary facility person, and also Changwan Lee, who does research on viral destruction. And I'll just go through this sort of quickly, but just a little bit of background on our state and different types of mortality disposal, which you are all familiar with, I believe, and then some basic composting principles, and then some tools we've developed for depopulation composting here in the state. And we're still working on these. These are just sort of getting going. And some research we proposed. And then finally, I think the most interesting part is the IR temperature monitoring part. So Ohio is one of the largest egg producing states, in addition to Iowa. And for a period, we were the largest when Iowa was having problems with avian flu outbreaks. So our focus really is on layer facilities. We also have many broiler facilities as well, though. And you know all of this background, but the options for mortality disposal really for broilers are in-house mortality composting, but for layer houses, there's the options for in-house composting are very limited if they exist at all. So in our state, our Department of Agriculture allows these various methods for mortality disposal, and as you heard from the previous speaker, that really composting appears to be the best option. In Ohio, our water table is fairly high, so burial is a difficult choice. Rendering isn't really allowed. Landfilling is difficult, and there's not really the capacity for burning of the carcasses. So a few lessons that I've learned, and these may or may not be completely correct from the Iowa outbreak because they're secondhand, but only a few facilities did on-site composting, 3 out of 105 farms apparently, and only 1 layer operation. Rendering of pathogen contaminated carcasses was prohibited, and on-site burial presented issues with water quality and environmental contamination. And also on-site incineration capacity was exceeded. So there's lots of issues with the methods that were used. And in addition, we don't want to be transporting carcasses along the roadways that may be infected to other sites. So broiler facilities have these options of in-house composting where there's plenty of room and the ability to make a windrow. And there's guidelines for doing this that you guys have developed, which are excellent. Layer facilities are a little bit different, and this is showing one of the layer facilities here in central Ohio. Each of these houses can contain 150,000 hens, and these hens produce for 1 or 2 years, and they live in stacked cages. Now, one interesting thing is that these houses are routinely depopulated after 1 to 2 years. So they have routines in place for cleaning out these houses within a few days, actually. 42,000 birds per day can be removed from the houses and disposed of. They're usually placed in these wheeled boxes that contain carbon dioxide, and then their mortalities are used to make animal feed in rendering facilities. Our largest farm has about 6 million hens. And in these facilities, there's also quite a bit of manure, and that's usually belted to large 60 by 300 foot buildings where it's stacked and sort of composts naturally. but in-house composting is not really possible. And you can see that from this slide here. There's belts that move the eggs in one direction and the manure in the other direction, and aisleways, and that the hens are on multiple levels. There's really no free space inside the building. Another thing is that when this happens, they like to have the animals removed as quickly as possible, because if they die inside the cages, they create a huge mess to clean up very quickly. So they like to clean out the houses within a very short period of time. So this shows one of these entire houses here from the outside. And then this shows one of the days they were doing depopulation. So they have these trucks here. They remove the birds from the house. And what you see there is a conveyor. They're actually just grinding up the birds and then putting them into these tanker trucks. And then they drive the tanker truck away with these ground up birds. And it takes 2 or 3 days to clear out one of the houses. But we don't see that as an option if there was a flu outbreak in these houses. So this is something we've been considering here, which is really slab composting. And it's a little different than windrow composting in that it can contain a much larger volume of material. And it's practiced on sites that have a limited amount of space, usually for yard trimmings composting. You can see a facility here and what the scale of that is with these slabs. It has a much smaller footprint than what would be needed for windrows. Less frequent turning can be used compared to windrows. Of course, we're not turning that frequently anyway. These have higher temperatures that may be more conducive to destroying the pathogen. They can use existing farm equipment like loaders, for example. There's simpler leachate and dust control from these in an outdoor site. And the house can be cleaned, as we heard from the previous speaker, that the house could be cleaned potentially while the composting is going on outside. So we developed a model to sort of predict the size and amounts of amendments and CN ratio and moisture content in these slabs. And some of the assumptions we used were that the birds had a weight of about 4 pounds, CN ratio of about 5 to 1, and an 85% moisture content. And some of those data is available in some of the sheets that you've developed already. Our slab height would be 6 to 8 feet with a base of 2 feet of wood chips or mulch. And then it would have biofilter covering the tops and both sides completely on all sides to filter out odors and absorb moisture. The amendment to bird ratio would be 6 to 12 cubic feet to cubic feet, and that's based on the literature which we've reviewed and come up with this value. Wood, mulch, and yard trimming amendment would be used, and the whole slab would be turned after 20 to 30 days, or it could possibly not be turned for a longer period of time. And then an advantage of this and the other composting methods is that you could potentially sell the finished compost at the end of the process, or at least use it for agriculture to recoup some of the money that you may have spent for the amendment. So in our model, we try to optimize the composting process based on CN ratio, moisture content, porosity, aeration, and pile size. And I'll just walk through that quickly. So the ratio of carbon to nitrogen, as you know, is the CN ratio, and it's measured by a soil testing lab. And high CN ratios in compost will slow the composting rate, whereas low ones will lead to the release of nitrogen as ammonia or possibly as odors. And the rule of thumb is it should be 30 to 40 to 1. And if you look at nitrogen loss during composting, you'll see that if even at 30 to 1, which is recommended, you can lose 30% of the nitrogen as ammonia. So we want to be closer to around 40 to 1 to 50 to 1 to remove so that much less ammonia emission is occurring. Moisture content is important. Too little moisture can inhibit the microbial activity, and too much can lead to oxygen diffusion limitations and anaerobic conditions. And the ideal we're shooting for with our model is 55 to 60%. And this is a problem that can happen if you have too little moisture content, spontaneous combustion in these large piles. This usually occurs when the moisture content is between 22 to 30%, so very low moisture content, and when you have wind blowing against one edge of a windrow. So there's also physical factors that affect decomposition. We want to have rigid particles to provide structure, especially in these larger slab systems that allow convective air movement. So one thing we do is a layer of wood chips at the base of the windrow or of the slab to allow movement from beneath the slab. And this just shows some relationships between porosity and oxygen concentration. If you have very porous material, oxygen can be convected within these piles very easily, whereas in a typical type of sawdust and manure windrow, you have very low oxygen concentrations because the movement is hindered by the porosity. So what we're relying on here is passive convection for aeration, and not by turning. You all are aware of that, but it's sometimes not understood by farmers that you don't need to turn these windrows. You need to set up a system where you have passive convection, which is occurring due to buoyant air, heated air in the center of the material. One limitation with a slab is there's not a very easy way for air to get into the slab, and so the porous base is necessary for that. So a few things we've developed is this OSU. It's an avian flu slab composting spreadsheet, and it's similar to like the compost optimizer at MSU. It's not nearly as well developed as that. And we've also developed some GPS information for amendments that are available based on Ohio EPA information and also biocycle information. And then I'll just talk about a couple studies we did, or case studies using our model and some information that it gave us. So we looked at the literature for setting up these mortality composting systems, and there's a lot of different guidelines from different information about how much bird to amendment is needed, and these are all in different units as well and difficult to interpret. So we sort of looked at all of those and picked sort of the best one we could come up with, and our guideline is really that our amendment to bird ratio should be 6 to 12 cubic feet per cubic foot, and that can be converted into other units. But this just shows our spreadsheet. To enter the number of birds, the bird weight, and volumes of available amendments, and those are all these yellow cells. And the blue cells, we only have a limited number of amendments that we've chosen, which include sawdust, fresh and old, poultry manure, straw, wood mulch, double grind wood mulch, leaf compost, corn stover, and wood chips. And these are ones that are fairly well available around the state for this type of application. And then we define the height of the slab and the width of the slab, and then it tells us the length and the area of the slab, or the acres that would be taken up by the slab, and also the size of the biofilter. It also tells us, based on our feedstock properties, how much water may or may not need to be added to get to an optimum moisture content. And then it estimates the cost of the amendment and also potentially the value of the finished compost at the end. So here's one case study, just sort of putting some numbers into our model. And this is a 150,000 bird event. And the amendments we chose were poultry manure, which is available at the site, and also wood shavings or wood chips, and some leaf compost. So you can see we have some of the poultry manure, which we may or may not need to compost as well. But when we add that material, we have a cost of about $33,000 for amendment, an acre, about a quarter of an acre slab size, and a moisture content of 53%. But our CN ratio is fairly low, meaning we would have nitrogen emissions from this slab. So we did another case. You can see that there. So our conclusion from this is we don't want to use the manure. We want to let that really compost in place or already where it's located, rather than mixing it in with these slabs. So here's another case study we did, just looking at yard trimmings, which are fairly widely available, and wood shavings or wood chips. and the cost for that was just a little bit more, $41,000, a little bit larger size, a quarter of an acre. But the CN ratio is about 30, and the moisture content is near optimal. It's 56% for this. So from this, we developed, for these cases, these sort of easy sheets that you can just look at quickly and determine how much amendment you might need. So a farmer could really look at this and say, oh, I have 100,000 dead birds. About how much of these different amendments might I need? And so he can just go up on the chart and say, oh, I need about 1,300 cubic yards of sawdust, leaf compost about 900, wood chips this amount. And so from the model, we could just, based on a certain situation, give these amounts of amendment that would need to be ordered or purchased for that case very quickly. And then also, it can predict the amount of water and the area of the compost slab as a function of the number of birds that need to be disposed of. So some other considerations, and I'll just talk about a few of these, are siting. We have rules here for composting sites where water all must be collected and then used on site or sent to a wastewater treatment facility. So we're not sure how that would work actually in the case of an outbreak where we need to have a composting site approved by Ohio EPA. Feedstock availability is an issue, so we've GPS located different feedstocks around the state. What to do with the finished compost. Equipment that may be needed to construct these may or may not be available. Transportation of feedstocks, staging, leachate, and stormwater runoff are also two big issues. So this is a map of Ohio showing the poultry farms in the state. The large hen operations or layer operations are the colored ones, and the broilers are the dark colored. So you can see they're not really well distributed. They're mainly on the west part of the state, and in the center of the state is where the hen houses are. And then on top of that, we have wood, sawdust, and mulch sources, which we've GPS located. You can see most of those are located in the center and eastern part of the state and the south, so not very close to the location of the poultry houses, or the hen houses at least. So the other locations we've GPS located are composting facilities, and the composting facilities are better distributed and closer to the location of the hen houses. So this material may be more available than trying to source wood or wood shavings. You also see that the size of these varies from small, just less than 1,000 cubic yards per year, up to greater than 100,000 cubic yards, usually around the urban areas. We have a list of the largest compost sources in the state, and these go from 200,000 yards down to 35,000 yards. Those are the top 10. But we would need for 150,000 birds around 2,000 to 5,000 yards. So the availability of feedstock seems to be pretty good if we're going to use yard trimmings. So what we did is we created a map of the composting facilities where you can just click on the location. If you were, like, for example, a farmer in the west part of the state, you can actually see the closest composting facilities, click on those, and it shows what their volume of material is, and then has their phone number where you can call them. So just a little bit about some research which we've proposed to look at virus inactivation during this process. We proposed to create some experimental containers made out of some insulation material, really, where we could do triplicate treatments and then take samples at 4 time periods. And these would resemble that slab construction where you'd have wood chips at the base, you'd have possibly forced aeration or just passive aeration, and then the entire cube of material could be removed, and then the material inside each one could be removed and analyzed. So what we proposed to do was to take 40 8-week-old layer hens infected with H5N1 low pathogenic A1 virus, and then also some chicken tissues that had been contaminated with A1 virus, as well as Newcastle disease virus, which was a surrogate for the the highly pathogenic virus. And then we would take samples of these individual reactors would be completely sacrificed and sectioned. We'd measure the concentrations of the virus over time, and really just to confirm that there's virus destruction during the process. Okay, so I'll just move on to the next part of this, and this is a little bit more interesting and fun. It's the temperature monitoring of compost windrows using infrared photography. And this is just based on these inexpensive infrared cameras, which you can attach to an iPhone or an Android. So this is called the FLIR 1, and I don't have anything to do with this company, but it's just the one that I happen to get. And they have another one that they've released recently called the FLIR Plus. And it has a thermal resolution of 160 by 120, which sounds small, but actually the pictures are pretty good, and I'll show some of those. And you can simultaneously take infrared and visible pictures. And you can it can monitor temperatures between -20 to 120 C, plus or minus 3 degrees C. So the accuracy is okay. The battery life is about an hour, so the battery runs out kind of quickly. And it also has a spot meter where you can actually touch the image and it will show you the temperature at that location on the image, which is interesting and helpful. So here's an example of a photograph from that camera. And what I see is a 3-week-old windrow at the top, a 3-month-old one turned 30 minutes ago in the middle, and then another windrow which we just turned part of it, but not the other part. And so this is the visible image, and then here's the infrared image from that camera. And what you can see is, first you can see that the 3-week-old windrow at the very top of the screen there is much warmer than the 3-month-old windrow, which is in a cooler temperature. And then the interesting thing is here, we've cut the windrow in half with the turner. You can see the gradations of temperature within the windrow. Then you can also see where it's been turned, where the hot material has been really mixed with the cool material. So it provides a real interesting image of the process. This is the spot temperature measurement where you can just touch something and it will tell you that temperature at that location. So you could potentially touch different locations of the image to show you the temperature at the base, at the top, or even within the center of the windrow. And there's different color schemes that you can use. Of course, the actual image is just black and white and grayscale, and they use color to try to enhance that grayscale appearance. But what you can see from this image of a windrow, which hasn't been turned, is just the natural passive convection occurring during the composting process. You see the high temperature at the peak of the windrow, and at the base of the windrow, you see very cold temperatures. That's actually where air is being sucked in by passive convection, and it's cooling the base of the windrow below actually the temperature of the pad. So you can see that movement. This would be an interesting way to document, I think, windrows, either broiler house windrows or outdoor windrows during these pathogen flu outbreak composting events. This shows a windrow turner. It kind of looks like a rocket ship going on. You can see the cool temperature, and then as we turn the windrow, all of that hot material is mixed up. And this shows a windrow which we turned in stages every half hour. So the back stage you can see is already cooled down. This is just about an hour after turning. The middle stage is about a half an hour turning, and we're just turning this part. So you can see sort of how it's cooled down over time. This just shows an unturned windrow, again showing sort of the air movement, passive convection, where you see the high temperatures at the top where air is moving out and lower temperatures at the base. This just shows a larger back view of the windrows, sort of showing colder temperatures at the end of the windrows, and then those higher temperatures in the middle, and then there's some people there you can see. Here's another sort of showing a more active windrow. You can see the windrow itself is sort of an orange color, and where it's turned, it's heated up to even higher temperature. but it's higher than the ambient temperature around it, even in the unturned part. And this shows people sometimes don't look that great with these cameras. One of my students here, her hair makes her look kind of like a clown because the top is red and the other parts are sort of blue. But anyway, here's another interesting photograph. So just in conclusion, this low-cost IR photography provides a simple, quick way to remotely monitor composting temperatures and temperature gradients, and I think it might be useful for some of the applications that we may want to use them for. Okay, that's all I have. Uh-oh.
Thank you, Dr. Michelle. That was really lots of great research. So are there questions for Dr. Michelle?
Hi, this is Lori Miller. Thank you so much, Dr. Michelle. That was really interesting. Do you have any information on the correlation of the temperature at the peak of the windrow versus 18 to 36 inches deep within the windrow? So I know that you said when you took that picture, those pictures, you could touch the location and get the temperature at that location. And so if I touched the very peak of a windrow where it's orange, what would that tell me, if anything, about the interior temperature?
Well, usually the highest temperature will be just below that peak because there's a little bit of cooling that occurs when it comes out, but the air is moving up and out of that. But your question, could you correlate that temperature right at the peak to the internal temperature? I think you could conclude that the temperature inside the windrow is higher than that, but I don't have we haven't done yet any sort of correlations between these images and the windrow temperatures measured with a thermometer.
Okay, and when you were doing this work, what temperatures were you getting at the peak of the windrow?
We would get, let's see, at the peak, for example, in this image, we were getting temperatures of like 50 degrees C in that peak area.
Great, thank you so much.
Sure.
Hey, Fred, this is Gary.
Hi,
I
Gary.
was interested in the slab composting. Is that a layered process or a mixed process? How do you build that slab composting system?
Yeah, at this point, it's a concept. We haven't actually practiced it yet. So I believe that's the way we would do it. We would layer the birds, put in a layer of the amendment material, and another layer of birds, another layer of amendment material. It may be difficult to drive up there, so that's something we've trying to sort of understand how we might do, because we don't want to compact the material too much. But any ideas you might have, I think we'd be happy to think about. Still there?
Yes. Are there any other questions for Dr. Michelle? And I know there was some talk about using drones over composting windrows to do infrared monitoring. And is that something that you've looked at?
That's something I heard about, but we haven't done that. We've just done these sort of from a distance in this way, just sort of taking a direct picture. But that seems like that might be an interesting application.
Okay. Well, thank you very much. Any other questions for Dr. Michelle? Well, thank you so much. We really appreciate your presentation, and it was lots of great research. And so I guess we'll sign off for this call unless there's any other questions or comments. Okay. All right. Well, thank you. So we'll have the next conference call in August. So we'll get information out on that. So thank you, Dr. Michelle.
Thanks for the opportunity.
Thank you.
Thanks, Arlene.
Thank you.